Hello everyone, good morning. Just give me a minute. Okay, myself Priya again. I'm a top educator in the category of EAMCT. I've been teaching on an academy platform from past 4 months, and also in the offline mode I teach for different category of students like JEE, NEET, and also CET category of students from different places, different colleges. And under my supervision, I have produced a good number of ranks with a better ranking. And in the offline mode, I have taught many different students for almost 4 to 5 years. And presently, I'm working at one of the prestigious college and also on very prestigious online platform that is Unacademy. So all of you can join for the plus courses. So the plus course details I'll be giving you now. Just give me a minute. So all of right. So let us move on for our classes. Yeah, great. So this is about the plus subscription. All of you can go for different plus subscription plans. So there is a 12-month plan on an academy which you can opt for, and there is also a 6-month plan, and there is a trial price of 1 month, right? So 12-month plan costs you around 12,375 rupees, and 6-month plan costs you around 10,125 rupees. And also there is a trial price for the new subscribers only, and that is only for 1 month, and it is 2,250 rupees. So all of you can go for this plus subscription and enjoy the benefits of plus subscription. So if you want to have a 10% off, if you want to have 10% off on any of the subscription plans, then you can use this code PRKLIVE. If you use the code PRKLIVE, you will be getting 10% off on any of these subscription plans. Okay, so that is my code PRKLIVE. Use this code to get 10% off on any of this subscription plan. Now, what are the benefits of opting plus subscription? It is giving you premium content at very affordable price. Structured live courses are there. Live doubt clearing sessions will be organized, and quiz will be organized at regular intervals for self analysis. And there will be separate batch for complete preparation of the subject. Daily practice papers, that in short we call it as DPPs, will be provided, right? Full length mock test will be conducted to analyze your subject knowledge, your preparation. And under a single subscription, you will be having unlimited access to the content on Unacademy platform. So all of you go for this plus subscription and use the code PRK Live. So this is about the EAMCT Rankers Match, which is conducted on Unacademy platform. You can also find the link to my profile on Unacademy, where I take complete preparation of all the subject matter. You can go to the description box of this particular video, and you will be finding link to my profile on Unacademy platform. Please follow me on Unacademy and attend the classes regularly. So yeah, in the last class we have studied about the atomic radius, shielding effect, and different blocks of elements, and also we have studied about the years from where the periodic table has been classified, who all has classified those periodic table, and what are the different difficulties that were faced by him or her, right? So different things we have looked into, and let us move on to the next very important concepts from this particular chapter. So in the last class also we have discussed whatever trends we are going to discuss in this particular chapter, right? Okay, so let us begin. So ionization enthalpy. So first you should know what is the meaning of ionization enthalpy. So ionization enthalpy is one of the quantity that measures the tendency of any element to lose electron. Okay, so how can we define this? So ionization enthalpy is nothing but the amount of energy. Enthalpy, you know, it is meaning of nothing but energy, right? So enthalpy is nothing but energy, right? So what we say is ionization enthalpy is defined as the amount of energy required to remove an electron from the outermost shell. Okay, it is nothing but amount of energy required to remove an electron from the outermost shell is known as ionization enthalpy. Now how this is represented? It is represented as delta IH. I stands for ionization enthalpy. Okay, delta IH. So if you are removing the electron is removed from a isolated gaseous atom in its ground state. Okay, so we can still further modify this definition. Ionization enthalpy is defined as the amount of energy required to remove an electron from an isolated gaseous atom in its ground state. Okay, that's the complete proper definition of ionization enthalpy. So it is represented by delta IH, right? So if you consider any element X and you are trying to remove an electron from it, then if you remove an electron, it is going to gain a positive charge over it and the electron is released, right? The electron is released. Okay, now what is the unit? So definitely it is ionization enthalpy. So definitely it will be having certain units also. So ionization enthalpy is expressed in terms of kilojoule per mole. Okay, it is expressed in terms of kilojoule per mole. And if you have joule per mole, then if you want to convert it into kilojoule per mole, divided by 1000. Okay, right. So this ionization enthalpy is completely dependent. It is completely dependent on the size and the nuclear force of attraction, effective nuclear charge. These all things we have to consider up here. So there are two different things that you need to learn here. So first one is, let us imagine there is an element and it is losing an electron. So if it loses one electron, it is going to get one positive charge. Plus one electron is released. Now, amount of energy required to remove this one electron, we would call it as ionization enthalpy 1, because this is the amount of energy required to remove the first electron. That is the meaning. Now, if I want to remove the second electron, then the state of that element would be X plus, correct? X plus. And I'm removing the second electron from it. Again, it will get one more positive charge. Already one positive charge is there, so it will be 2 plus. Plus one more electron has been removed. Correct? So this energy would be ionization enthalpy 2. Now, why I have taken this concept is, see, if you are removing the first electron, you are removing it from the outermost shell. Okay? You are removing it from the outermost shell. So that we'll call it as ionization enthalpy 1. Then, ionization enthalpy 2 would be the amount of energy required to remove electron. Hello, welcome Anil. Thank you so much for joining and very good morning. Welcome to my class. You can follow me on Unacademy also, where you can find the profile to, where you can find the link to my profile. So you can attend all the classes there itself. So you can say that if this is an innermost orbital electron, okay, if this electron which we have removed, if it was present in the innermost orbital, then definitely their nuclear force of attraction would be high and that electron would be more tightly held. Right? So ionization enthalpy 2 would be more or greater than IE1. So as you go deep inside the atom, the shells will be more closer to the nucleus and they will be more tightly held. And once they are more tightly held, we need to provide more amount of energy to pull that electron out, right? So that's how you need to be aware of from where you are actually removing the electron, from which orbital you are trying to remove the electron, and how much energy would it be more or greater or lesser than the amount of energy required to remove the electron from the outermost shell. Now, whether this ionization enthalpy values they are positive or whether they are negative, that is the question. Okay, so always these amount of energy we require, right? We actually require the amount of energy to remove electron, correct? Therefore, whenever energy is required, it would be always positive. It would be always positive, right? Okay. Now, as I said, the second ionization enthalpy will be higher than the first ionization enthalpy because it is difficult to remove an electron from a positively charged ion. Now, when we are removing the second electron, we are removing it from the positively charged ion, right? Than from a neutral atom. In the same way, if you go for removing the third electron, that is from K X3 plus will be formed. When X3 plus will be formed from X2 plus, then again it will be more higher. So if I just generally say IE3 would be greater than IE2 than IE1, right? So it's always difficult to remove an electron from a positively charged atom than from a neutral atom. In the same way, third ionization enthalpy will be higher than the second and so on. The term ionization enthalpy is not qualified if is taken as first ionization enthalpy. Okay, let us move to the next one. Okay, so as I said that the amount of energy required to remove the electron from the atom and hence the ionization enthalpy values will be always positive. Now, when you move from left to right in a periodic table, from left to right in a periodic table, if you are moving, let me just change the ink of this pen. Okay. When you are moving left to right in a periodic table, you know size, atomic radius or atomic size decreases because the next electron, whichever are added, they are added into the same shell. Size decreases and therefore what we say is effective nuclear charge or nuclear force of attraction increases. That means the nucleus is holding the outermost electrons very tightly, right? If it is holding the outermost electrons very tightly, then it is difficult for us to remove the electron and therefore we need to provide greater amount of energy to overcome that force of attraction. Therefore, ionization enthalpy increases. Ionization enthalpy increases. So this is the image that represents the ionization enthalpy, how it increases. So lithium, the first element of second group and the last element of second group, neon, right? So as you move from lithium to neon, size goes on decreasing. Therefore, ionization enthalpy goes on increasing. You can see here for lithium it is 520 kilojoule per mole, but as you move on it is 899, 801, 1086, 1004, so 1402, 1314, and likewise highest would be neon, that is 2080. Now one thing you have to just check here, that in nitrogen though it is just let me use pen. Yeah, nitrogen you can just observe it is having an ionization enthalpy of 1402, whereas it is before oxygen. Actually oxygen should have more as compared to that of nitrogen. But then why nitrogen has greater ionization enthalpy here? If you compare the values, definitely oxygen should have greater one. Why? Because size of oxygen is even smaller than that of nitrogen. But then why nitrogen is having more ionization enthalpy? Why nitrogen is having more ionization enthalpy? The reason is, if you write the electronic configuration of nitrogen, you know atomic number of nitrogen is 7. If I write its electronic configuration, 1s2, 2s2, 2p3, So this is the outermost orbit. You can just check there is extra stability of half-filled configuration. So to break this extra stability which is already present in the molecule or atom, then we need to provide greater amount of energy. So due to presence of this extra stability in half-filled configuration, then that is the reason we need to provide greater amount of energy, and hence nitrogen has greater ionization enthalpy than that of oxygen, right? And maximum is in noble gases. Okay, maximum would be in the noble gases. Okay, so let me just check how things are going on. Okay, all's well. Great. Let us move on to the next one. That is in a period. Okay, in a period. You can check here: lithium, sodium, potassium, rubidium, and cesium. Lithium, sodium, potassium, rubidium, and cesium. These are first group elements. Okay, Li, Na, Ki, Repse, friendship. Francium actually it is radioactive, so we do not consider it here. Its half-life is very less, and thus we do not consider it here. Anyways, so let us see how it is going to vary in these cases. Okay, right. So from top to bottom, let me go into the. So you can see lithium is having more ionization enthalpy, like somewhere around 500, near to 500. Well, cesium is somewhere around 100 or something. Okay, so last member of the group is having least one. So I'll just show it up here. So from lithium to, if you're just taking this example of first group, that is from top to bottom, that is from lithium to cesium. Okay, lithium to cesium. Francium is a radioactive element, so we are not considering it here. So from top to bottom, size decreases. So size increases. From top to bottom, size increases. As size increases, nuclear force of attraction decreases. Means the nucleus is not holding the electron of the outermost shell very tightly. Now, why is the size is increasing? As we have discussed in the last class also, the size increases because at every step a new shell is added. Right? At every step a new shell is added, and therefore size increases, and nuclear force of attraction would decrease. Okay, nuclear force of attraction would decrease. Once the nuclear force of attraction decreases, therefore the electrons are less tightly held. So we need to provide very less amount of energy to remove the electron from the outermost shell. Therefore, ionization enthalpy would decrease. Means the amount of energy required to remove the electron from the outermost shell would decrease. Okay, so that's how you need to analyze each and every graph that you observe, each and every concept that you learn here. Okay, great. Let us move to the next one. Something called as a shielding effect. So in multi-electron atoms, so where there are more number of electrons, the electrons present in the outermost shell, and they do not experience a full positive charge, and hence they are shielded or screened away from the nucleus. What is the meaning? Okay, it's so difficult to understand like this. So first let us see shielding effect. It is also known as screening effect. Okay, it is also known as screening effect. So what is this shielding effect or screening effect? So let me just consider one particular atom like sodium. Okay, like sodium. So sodium atomic number is 11. If I draw its K element configuration, 281. So 2 electrons in the S shell, 8 electrons in the K shell, L shell, and then M shell. Okay, so this was K shell, this is L shell, this is M shell. Okay, so KLM. So 1, 2, 3, 4, 1, 2, 3, 4. Great. Alright. So here you can just see in this KLM shell, and we have 2 8 and 1 electron. Now this nucleus, as you know, it is positively charged. It will be having more attraction towards this K electrons, a little less attraction towards L electrons, and very less attraction towards this M electrons. Why? Because the distance is increasing, right? Distance from the center of the nucleus to the outermost shell, it is increasing, and therefore nuclear force of attraction also decreases, right? The nuclear force of attraction also decreases, and due to this reason, that is decrease in the overall positive charge experienced by the outermost shell, the size increases, or this effect we will call it as shielding effect. Okay. Now what happens? These electrons are also negatively charged in this shell, and this electron is also negatively charged, which is there in the M shell. They will also experience certain type of repulsion among each other. So that repulsion between electrons present in the adjacent shell is known as shielding effect or screening effect, or else it can be also defined as the decrease in experience of the electrons present in outermost shell of the positive charge is known as shielding effect. Okay, so this is about shielding effect. Now this ionization enthalpy and atomic radius, they are related in two different ways. Okay, so first one is the attraction of electron towards the nucleus, because nucleus is positively charged and electrons are negatively charged. So if the attraction is good, then it will be holding the electrons tightly. The electron repulsion of electrons from each other, as I just mentioned, electron-electron repulsion would take place, right, from one shell to another shell. The effective nuclear charge experienced by a valence electrons, that is the electrons in the outermost shell. So that's the aeroplane that's going. I stay nearby airport, so I'm sorry for the inconvenience. I cannot control that. Yeah. The effective nuclear charge experienced by valence electron in the atom will be less, right? Because that's away from the nucleus, and therefore the nucleus will not be having much effective charge over that, right? On the nucleus, because of shielding or screening effect of the valence electron from the nucleus by the intervening core electrons. So what happens? What is the meaning? I'll tell you. When there is a repulsion between the electrons from the adjacent shells. See, M shell will be repulsing the electrons from L shell. L shell will be repulsing again the electrons from K shell as well. But K and M will not be having effective repulsion. So due to this repulsion, this orbital will move a little away. Due to repulsion, this orbital will move to a little away from the nucleus. Again, as it has moved away from the nucleus, the effective positive charge on these valence electron will be reduced, right? And that is known as screening effect or shielding effect. Okay, I hope you have understood that. Now coming to anomalous properties of something related to shielding effect. Okay, so what are the different anomalous properties related to shielding effect? Let us just see. Okay, just give me a minute. Let me just check. If anyone has a doubt, you can comment in the comment section. Okay, great. Yes. So 2s electrons of lithium is shielded away. Now why? Why this happens? Okay. So 2s electrons in lithium is shielded from the nucleus by inner core electrons of 1s. So let us see what is it's all about. Lithium, atomic number is 3. Hydrogen, helium, lithium. If I write its electronic configuration, 1s2, 2s1. Let me draw it. So K shell will be having 2 electrons and L shell will be having 1 electron. So this electron-electron repulsion will occur. Okay, here you can experience electron-electron repulsion, and that electron-electron repulsion we call it as shielding effect or screening effect. As a result, the valence electron experiences a net positive charge which is less than the actual charge of +3. So what happens when the repulsion has taken place? As I mentioned, it will move little away. The outermost shell will move little away. And if it has moved little away from the nucleus, then this nucleus will not be having even any attraction towards this orbital as it was there in the atom in the previous one. Okay, before shielding, right? So this is how we say that 2s electron of lithium is shielded away. I mean, so moved away. Okay. This situation occurs in case of alkali metals which have single outermost electron. Okay, because here in the inside orbital you will be having two electrons. So those two electrons can effectively repulse this one electron, right? So whenever you have one electron in the outermost shell, most of the cases of shielding are observed in the alkali metals because there is only one electron in the outermost shell of what we say alkali metals, right? Okay. So if you have any doubts, you can ask. Yes, all of you. If you have any doubts, you can ask me. So my next YouTube session will be on 11th, that is on Monday at 8:30 p.m. and the topic that will be dealt is periodic classification of elements, right? So be ready for the topic periodic classification of elements, and YouTube session will be on 11th at 8:30 a.m. same timing, and continuation part of this will be there. We'll see in depth, and some MCQs will also be conducted, and you can also attend my Unacademy classes. The link to its profile link is provided in the description box of this particular video. My Unacademy classes were also taken regularly on each and every topic with more than 200 MCQs that has been solved in each chapter with explanation. So all of you can join for Unacademy classes also, and definitely I'll be going live on YouTube on 11th of this particular month. That is probably on Monday, right? And in this YouTube session, we'll be having or we'll be solving certain MCQs, okay, multiple choice questions relatable to this particular chapter, okay. So whatever little things we have studied in this chapter, the continuation part of that will be taken up. So if you have any doubts, I'm just waiting for your doubts in the comment section. So if you can comment in the comment section. And it's good to see you people in the class. Yeah, if you have any doubts, you can ask me. Yes, all of you. Feel free to ask any of your doubts. Okay, I think you don't have any doubts. Very good. That means my work is done. That you have understood the concept. Great. Thank you so much, all of you. And please attend the classes regularly, and follow me on Unacademy, and attend the classes on Unacademy as well. Right. Thank you so much. A good day, and yes, um, always strive to learn more, learn better, and learn from the better. Okay, so Unacademy provides you a very good opportunity uh, by providing number of free classes, and you should make use of that and learn from very good educators that are present on an academy platform. And please go for this plus subscription. So as I explained you about the plus subscription, you can use my code PRKLIVE and get 10% off. So see you all people on 11th of this month at 8:30 a.m. and be prepared for different questions that I'll be asking from this particular chapter. So thank you so much. Have a good day, and yes, keep learning.